Breathe gently, close your eyes, and let me tell you a story about the most distant planet. Slow your breathing down, make it light and soft, as if you are drifting through the pitch black of space. There is no need to rush, the night is still long, and we have plenty of time. Imagine that we are aboard a very quiet spacecraft right now, slowly floating through the boundless cosmos. Outside the window, there is no sound at all, only the faint, distant glow of starlight quietly twinkling. We are following in the footsteps of Voyager 2, flying toward the most remote corner of the solar system. Directly ahead of us, a faint blue planet is slowly coming into view, radiating a gentle and peaceful glow. This is Neptune. Neptune is the eighth planet of the solar system and the farthest planet from us. Its distance from the Sun is 30 times the distance between the Earth and the Sun, more than 4.5 billion kilometers away. This distance is so great that even sunlight takes a full 4 hours to travel there. Just imagine how dark, how quiet it must be in that place. Because it is so far from the Sun, Neptune is also one of the coldest places in the solar system. Its average temperature is about -214 degrees Celsius, second only to its twin sibling Uranus. Interestingly, Neptune is sometimes farther from the Sun than Pluto. Pluto's orbit is a highly elongated ellipse, and every 248 years it crosses inside Neptune's orbit and stays there for a full 20 years. The last time this happened was in January 1979, and it continued all the way until February 1999. During that period, Pluto was actually closer to the Sun than Neptune. The next time it will happen is in the year 2227. By then, who knows where any of us will be. Neptune takes a full 165 years to complete a single orbit around the Sun. If you lived on Neptune, 1 year would equal 165 years on Earth. Ever since humanity first discovered it, it has not even completed a single full orbit yet. It is like a very patient elder slowly and deliberately pacing its way around the Sun. Its axial tilt is 28.3 degrees, very close to Earth's 23.5 degrees, which means Neptune also has 4 changing seasons. But each season on Neptune lasts about 40 years. A single winter would span your entire lifetime. Even though its orbit is so slow, Neptune's rotation is actually quite fast, with an average rotation period of just 16 hours. But the word average is very important here, because ice giants, unlike Earth, are not solid rocky planets. From its interior to its exterior, there is very little solid material, so different latitudes rotate at different speeds near the equator. It takes about 18 hours to complete a rotation, while near the poles it spins faster, completing a rotation in about 12 hours. This difference in rotation speed makes Neptune the windiest planet in the solar system. Its wind speeds are 3 times those of Jupiter and 9 times those of Earth. The highest wind speeds reach 2,200 kilometers per hour, which is over 600 meters per second, nearly twice the speed of sound on Earth. The strongest typhoons on Earth have wind speeds of only about 400 kilometers per hour. Neptune's winds are a full 5 times faster than anything on Earth, yet you cannot hear these winds. In the vacuum of space, even the most ferocious storms are completely silent. Within these violent but silent winds, there also exists a type of anticyclonic storm similar to Jupiter's Great Red Spot, called a Great Dark Spot. Voyager 2 discovered the first Great Dark Spot when it flew past Neptune in 1989. It was an oval-shaped giant storm, 13,000 kilometers long and 6,600 kilometers wide, large enough to swallow the entire Earth. But unlike Jupiter's Great Red Spot, which has been raging on Jupiter for over 400 years, Neptune's Great Dark Spot lasted for less than 6 years. By November 1994, the Hubble Space Telescope could no longer find it. It had completely vanished. At the same time, a new dark spot had appeared in Neptune's northern hemisphere, with a diameter of just 3,900 kilometers, called the Small Dark Spot. This small dark spot persisted until the year 2000, when it too disappeared entirely. Then in 2016, yet another dark spot appeared in the northern hemisphere, nearly as large as the original Great Dark Spot, called the Northern Great Dark Spot. These storms are like ghosts on Neptune's surface, appearing and then vanishing, vanishing and then reappearing, each one lasting only somewhere between 2 and 6 years. The reason they form and dissipate remains a mystery to this day. Now let us talk more about Neptune itself. Its diameter is roughly 49,000 kilometers, slightly smaller than Uranus, and about 4 times the width of Earth. In terms of volume, it is the smallest of the 4 outer planets, yet it is still 58 times the size of Earth. Its mass is about 17 times that of Earth, slightly heavier than Uranus, ranking third among the solar system's planets. Strictly speaking, Neptune should not be called a gas giant. It is an ice giant. Jupiter, from its atmosphere down to its internal ocean of liquid hydrogen, is composed mainly of hydrogen and helium, a composition very similar to the Sun's. But Neptune's main constituents are actually water, ammonia, and methane. The icy mantle formed by these substances is the main body of Neptune, making up more than 80% of the planet's mass, while hydrogen and helium make up less than 20%. That is why it is called an ice giant. But Neptune's ice is completely different from the solid ice we are used to seeing. Under the high temperature and extreme pressure of the planet's interior, this ice exists entirely in a fluid state. Hot, searing hot, boiling hot. You could never imagine here on Earth that ice can actually be boiling. At the deepest part of this icy mantle, a small rocky core is wrapped inside, about 1.5 times the size of Earth, composed of metallic elements such as iron and nickel mixed with silicates. Neptune has no solid surface. From the icy mantle upward, everything is atmosphere, composed of roughly 80% hydrogen, 19% helium, and 1% methane. This methane absorbs the red light from the sunlight, and that is why Neptune appears blue. Speaking of which, when you used to look at books, did you often see Neptune depicted as a deep dark blue? And yet Uranus always looked more of a cyan shade. If their atmospheric compositions are so similar, why would their colors be different? As it turns out, the answer is very simple. The images Voyager 2 sent back all those years ago were processed a bit too heavily. In order to better show Neptune's features, such as its bands and the Great Dark Spot, the scientists enhanced the colors quite aggressively. It was not until 2022 that a team from the Planetary Physics Laboratory at Oxford University restored the true colors of Uranus and Neptune. The results showed that Uranus' color was not changed much at all. It is still that delicate pale blue we have always known. But Neptune's true color is actually very similar to Uranus, only just slightly more blue. Why is it slightly more blue? Because Neptune's atmosphere is more active than Uranus. The methane in Neptune's atmosphere is not as thick as that on Uranus, so it absorbs less red light, and the blue appears a little deeper. So from now on, if someone tells you that Neptune is a deep blue, you can let them know that we have all actually been tricked by Voyager 2 for all these years. The story of Neptune's discovery is just as fascinating. Before Uranus was discovered, people had always thought that Saturn was the most distant planet in the solar system, but after William Herschel discovered Uranus in 1781, everyone suddenly realized that there were planets beyond Saturn after all. Many astronomers then began searching for new planets, but after searching for a while without success, they gradually gave up. So how was Neptune discovered? It was the first planet in human history to be found through mathematical calculation rather than direct observation. In other words, it was calculated into existence. In 1821, while computing the orbit of Uranus, astronomers found that the calculated orbit never quite matched where Uranus actually was in the sky. This problem troubled them for more than a decade. Then in 1835, the French astronomer Bouvard put forward a bold hypothesis. Could there be a planet that had not yet been discovered whose gravity was affecting Uranus' orbit? But a hypothesis is only a hypothesis. You have to actually find this celestial body to prove it, searching for one faint distant star in the vast sea of the night sky. How impossibly difficult that was, since direct observation was not easy. There was another method, to rely on mathematics. One could work backwards from the anomalies in Uranus' orbit to calculate where the unseen planet must be. This calculation process was extremely complex, but even so, two people independently succeeded in computing Neptune's position. One was John Couch Adams, a British astronomer and mathematician. When he was just 16 years old, he accurately predicted a local solar eclipse through calculation. After 2 years of relentless day and night computation, in September 1845, he successfully worked out the orbit and mass of Neptune and predicted where in the sky the planet would appear in October. The other was the French astronomer and mathematician Urbain Le Verrier, who in June 1846 also calculated Neptune's position. His results were almost exactly the same as Adams'. Two people who had never met, using different methods, arrived at the very same conclusion. But although both of these men were brilliant at calculation, neither had the means to conduct astronomical observations. They could only turn to the observatories of the time for help, but the telescopes at the observatories already had their schedules fully booked every day, and the idea that you could calculate a brand new planet into existence using only pen and paper, well, not many people believed it. So the request to borrow a telescope was delayed, again and again, dragging on for months, until September 1846, when Johann Galle, an astronomer at the Berlin Observatory in Germany, agreed to help Le Verrier ask the observatory director for permission to use the telescope. As luck would have it, the director was in a good mood that day because it was his birthday, and he finally said yes. That very night, Galle aimed the telescope at the position Le Verrier had calculated, and sure enough, he found a star that no one had ever seen before. Galle thus became the first person to ever lay eyes on Neptune. However, Galle always refused to claim credit as the discoverer of Neptune. He believed the honor belonged to Le Verrier. He even suggested that the planet should be named Le Verrier's star, but Le Verrier declined, and instead gave it the name Neptune, after the Roman god of the sea, corresponding to Poseidon in Greek mythology. This name was quickly and widely accepted, but the story does not end there. While France was still basking in celebration, the British produced Adams' calculation manuscripts from 1845 and argued that Adams had actually been the first person to calculate Neptune's position. It was just that Adams had been so absorbed in his calculations that he had never published his results publicly. The astronomical communities of the two nations debated fiercely for a long time. In the end, after many rounds of negotiation, they reached a consensus that Le Verrier and Adams had jointly discovered Neptune. Even more astonishingly, astronomers later combed through historical records and discovered that people had actually seen Neptune much earlier than that. They just did not know what it was they were looking at. The French astronomer Michel Lalande observed Neptune twice in a row in 1795, but the telescope he was using at the time had a chipped lens, and he assumed he must have been seeing things, that it was just an error. Just like that, he personally closed the door of destiny. Had he been just a little more careful, the discovery of Neptune would have come more than half a century earlier. There is another person whose story is even more legendary, and that is Galileo. Later scholars discovered in Galileo's observation journals that between 1612 and 1613, Galileo had seen Neptune at least twice. This was a full 230 years before Neptune was officially discovered. Like the other giant planets, Neptune has rings. Its rings may not be as magnificent as Saturn's nor as bright as Uranus, but they are much more beautiful than Jupiter's. They were first detected in 1984, but it was not until Voyager 2 arrived at Neptune in 1989 that the rings were photographed for the very first time. Neptune has 5 main rings, and each ring is named after an astronomer who contributed to the study of Neptune. The innermost ring is called the Gal ring, about 2,000 kilometers wide, and it is the faintest of Neptune's rings. Next are the Leverrier ring and the Adams ring, named after those two mathematical geniuses. The Adams ring is the brightest and most beautiful one. It is made up of 5 ring arcs named Fraternity, Equality, Liberty, and Courage. The brightest and longest arc is Fraternity, and the faintest arc is Courage. However, since 1986, the overall brightness of these arcs has been steadily declining, and the Liberty arc completely disappeared in the year 2003. The widest ring in the middle is the Lassell ring, a full 4,000 kilometers wide, named in honor of the British astronomer William Lassell, who discovered Neptune's largest moon, Triton. Along the edge of the Lassell ring, there is also a ring named the Arago ring, less than 100 kilometers wide. Speaking of Triton, it is Neptune's largest moon. It was discovered by Lassell just 17 days after Neptune itself was found, among Neptune's 14 moons. Triton is the only one that is spherical. The other 13 are all irregular in shape. Triton also has a very unique characteristic. It is the only large moon in the entire solar system that orbits in a retrograde direction. That means the direction it orbits around Neptune is opposite to the direction of Neptune's own rotation. This tells scientists that Triton was very likely originally a dwarf planet in the Kuiper belt, just like Pluto, and was later captured by Neptune's gravity. Like our own moon, Triton is tidally locked, always keeping only one face turned toward Neptune. Even more astonishingly, according to research predictions in recent years, Neptune's gravity is slowly pulling Triton closer and closer toward itself. It is predicted that in about 3.6 billion years, Triton will collide with Neptune and ultimately become a part of Neptune itself. Triton has a diameter of 2,700 kilometers, making it the 7th largest moon in the solar system, larger than Pluto. Its surface is extremely cold, with a temperature of about -235 degrees Celsius, covered mainly in frozen nitrogen. Yet even in this intense cold, when Voyager 2 flew past in 1989, it actually discovered geysers on Triton that can erupt up to 8,000 meters high. Scientists speculate that Triton's interior may also contain a subsurface ocean. Neptune's magnetic field is about 27 times stronger than Earth's, and its magnetotail can stretch for millions of kilometers into space. Both Uranus and Neptune share a very distinctive magnetic field feature. The direction of their magnetic fields is tilted at a very large angle relative to their rotational axes. Uranus is 59 degrees and Neptune's is 47 degrees, both vastly exceeding Earth's 11.5 degrees. Moreover, the center of the magnetic field is not at the planet's geometric center. It is shifted quite dramatically to one side. People used to think that Uranus' magnetic field was so skewed because the planet is lying on its side as it rotates, but after Voyager 2 visited Neptune, scientists realized that even though Neptune is not rotating on its side, its magnetic field is still off-center. So nowadays, scientists believe it is the fluid, icy mantle in the planet's interior that generates such a unique magnetic field. humanity's exploration of Neptune has been very limited. For more than 100 years after Neptune's discovery, we could only study it through telescopes, and all we could see was a blurry disk. This situation persisted until the 1970s, when a turning point finally arrived. In 1965, an engineer named Gary Flandreau discovered during a calculation that in the late 1970s, the four giant planets of the solar system would all be on the same side of the Sun, aligned almost in a straight line. By launching just one probe, it would be possible within a span of 10 years to use the gravity of each planet in turn to visit Jupiter, Saturn, Uranus, and Neptune all in a single mission. This kind of planetary alignment only occurs once every 176 years. The next occurrence will be in the year 2153, so NASA devised the Planetary Grand Tour program, which became the mission of Voyager 1 and Voyager 2. Voyager 2 launched first on August 20th, 1977, and Voyager 1 launched on September 5th of the same year. The two probes were identical in design, but had different missions. Voyager 1 was primarily to visit Jupiter and Saturn, especially Saturn's largest moon, Titan. Fortunately, Voyager 1 successfully completed its mission, but because it flew so close to Saturn, it received a much larger gravity boost from the planet, which deflected it out of the ecliptic plane. From that point onward, it could no longer travel to any other planets, including Neptune. On February 14, 1990, Voyager 1 was speeding away from the solar system at 65,000 kilometers per hour. At a distance of roughly 6.1 billion kilometers from Earth, it turned around and looked back toward the direction it had come from. It took one final set of photographs, 64 images in total, which when stitched together form a family portrait of the solar system's planets. In that family portrait, Earth is just a point of light, no bigger than a single pixel, a mote of dust suspended in a sunbeam. That is our home. Not long after taking this set of photographs, in order to save power, its cameras were permanently turned off. As of January 2024, it is 24.4 billion kilometers from Earth, the most distant human-made object in existence. Because Voyager 1's mission was carried out so successfully, Voyager 2 was freed to continue on to Uranus and Neptune, fulfilling by itself this once-in-176 years, once-in-a-century mission. In 1979, Voyager 2 showed us Jupiter's Great Red Spot. In 1981, it brought us a close-up view of Saturn's beautiful rings. In 1986, it let us feel the bitter cold of Uranus. And finally, on August 25, 1989, Voyager 2 reached its closest point to Neptune during the flyby. It discovered 6 new moons and 4 rings and recorded Neptune's atmospheric composition and its storm system, the Great Dark Spot. With that, Voyager 2 had completed its exploration of all 4 giant planets. This remains to this day humanity's only close-up encounter with Neptune, but the distance was simply too far. After completing all of its tasks, Voyager 2 did not have enough fuel to turn back. It too shut off its cameras and continued flying onward into the depths of space. As of January 2024, it is 20.3 billion kilometers from Earth. At its current speed, to travel a distance of 1 light-year would take roughly another 19,300 years. Beyond Neptune's orbit lies a disk-shaped region densely packed with celestial bodies called the Kuiper Belt. It is located roughly 40 to 50 astronomical units from the Sun and is composed mainly of small bodies and the leftover material from the formation of the solar system, including at least 4 dwarf planets: Pluto, Haumea, Makemake, and Eris. However, the total mass of the Kuiper Belt is quite small. The combined mass of every object in it adds up to only about 1/10 the mass of the Earth. Computer simulations show that Neptune has a very significant influence on the Kuiper belt. Without Neptune, the material in the Kuiper belt would have been able to coalesce into a true planet. But Neptune's powerful gravity prevents this material from assembling into a single body. Take orbital resonance, for example. Many objects in the Kuiper belt are locked in a 3-to-2 orbital resonance with Neptune, meaning that for every 2 orbits these objects complete around the Sun, Neptune completes 3. Pluto and Neptune share this same 2-to-3 resonance ratio, so even though their orbits cross, this delicate and precise resonance ensures that they will never actually collide. Beyond this, simulations also tell us that Uranus and Neptune did not form at their current positions, in the region where they now reside. The primordial material was far too sparse to ever produce bodies of such large mass, so they most likely formed much closer to Jupiter, and then through the complex gravitational interactions between the planets gradually migrated outward over the course of hundreds of millions of years. A vast and slow journey across the eons brought them to the places we see them today. When you think back on all of this, the universe truly is wondrous. Out there in the immense void of space, a faintly blue planet has been quietly orbiting the Sun for 4.5 billion years. Its winds are the fastest in the solar system. Its winters last for 40 years. Its largest moon runs backward along its orbit. Its storms appear and vanish like ghosts wreathed across its face. Its rings shimmer faintly in the endless dark. It is so very far away from us that humanity has only ever sent a single spacecraft to visit it, and that spacecraft has now traveled beyond 20 billion kilometers, continuing its silent drift through interstellar space, growing farther and farther away from us with every passing moment. Think of the Earth that we live on, in the scale of the universe. It too is only one tiny, tiny blue point of light. All of your worries, all of your anxieties placed against a scale like this, all become so very small and insignificant. In this moment you are safe. You are at peace. And now let these stories of faraway planets carry you slowly down into the land of dreams. Imagine yourself floating beside Neptune, surrounded by an endless sea of stars. There is no sound at all, only the gentle, pale blue starlight keeping you company. Your body is growing lighter and lighter, more and more relaxed. There is nowhere you need to go, nothing you need to do. You only need to be peacefully and completely in this very moment. Breathe slowly, sleep well, and may your dreams be tender and sweet.